Hello everyone, welcome back. In the first two videos, we have discussed computer systems and their hardware and software components. We have also discussed the difference between computer organization and architecture and the different classifications of architecture. In this last video, we are going to talk about one type of computer system out of the many types of computer systems. This is called embedded systems. So what are embedded systems? Embedded system is a type of computer system that does specific functions for a specific application, often within a larger system. You have to take note of the words specific functions and specific application. They are different from general computer systems like personal computers, where you can do a lot of functions for many applications that you want. Why talk about embedded systems? Because the increase of growth in embedded systems are remarkable since 2010 and will continue to increase. This graph shows the amount of IoT and connected devices projected until 2025. This includes smart home devices, wearable devices, connected vehicles, smart TVs, smart speakers and screens, internet media devices, tablets, smartphones, and other IoTs. All of these are embedded system devices. The number of PCs did not even grow because people are already satisfied with their smartphones. Embedded systems are classified into four types based on their performance and functional requirements. These are the standalone embedded systems, real-time embedded systems, network embedded systems, and mobile embedded systems. The first type is the standalone embedded system. These are independent systems which do not depend on larger computer system and do not need to connect to a network. Examples are your MP3 players, microwave oven, washing machine, calculator, digital cameras, temperature measurement system, and a lot more. So these devices takes input in analog or digital form, process the data according to what it was programmed to do, and then output the results as display or control to another part of the system. Next is the real-time embedded system. This type of embedded system can also be standalone, but they have a special feature that is strictly time-specific, or they must provide output in a particular time interval. This is further divided into two types: soft real-time and hard real-time embedded systems. In soft real-time embedded systems, the deadline of output may not be strictly followed, such as multimedia devices and telephone system devices. Video and audio outputs can have delays and is not catastrophic. However, further missed deadlines may cause the audio or video to lag or skip, which lowers the quality of the device. Hard real-time embedded systems, on the other hand, are those that must strictly produce an output within a deadline. These are used in life-threatening and catastrophic applications like airbags, military equipment, medical equipment, navigation systems, and many more. Imagine if the airbag in your car activates 1 second after an impact, or if it's so sensitive that it activates even with a sudden rush of strong wind. That is catastrophic, so this must be designed with high accuracy and efficiency. The third type is networked embedded systems. These are systems that need to connect to a network to provide output. They can be wired or wireless, and they are the fastest growing area in embedded systems application. Examples are your security systems and CCTVs, ATM machines, card swipe machines, embedded web servers, and so on. And then there's your mobile embedded system, which includes your portable electronic devices like mobile phones, MP3 players, digital cameras, Kindle, smartwatches, and many more. These devices are usually powered by batteries and has memory limitations. Given those types of embedded systems, what do you think are the important characteristics of embedded systems? So first, they should have low power consumption, especially when they are battery powered. Even if they are not battery powered, like in ovens and refrigerators, you don't want your embedded device to exceed the power consumption of other devices in the system. They should also be cheaper than the rest of the devices in the system. And if we are talking about mobile embedded devices, they should be small and lightweight so you can take them anywhere. But even if they are not portable like refrigerators, the embedded device should not exceed the area or weight of the other device in the system. They should also be easy to use with minimal and not so complicated user interface. They should have a fast response, high accuracy, and efficiency, especially with hard real-time embedded systems. And they must be stable and reliable over a long period of time. Just like other computer systems, embedded systems have the following components: a good power supply, a processor and memory, usually RAM, ROM, and EEPROM, and of course the input-output ports, or the I/O ports. And then to make sure that outputs meet the deadlines, there should be a timer or counter block. It also needs communication ports like UART, USB, I2C, SPI, etc. to be able to communicate with other embedded devices. It will surely have an ADC or DAC if it has analog inputs or outputs. And we will discuss this more in detail in the middle of our course. But wait, this really looks like a typical computer system and more. So how is it different with other computer systems, and how can we achieve the important characteristics of embedded systems as listed in the previous slide? The answer to that question is the use of microcontrollers. A microcontroller is a single IC that is typically used for a specific application and designed to implement specific tasks. They are used in replacement to processors or microprocessors. This is a simple block diagram of a typical microcontroller organization. All of these blocks are all integrated in one chip. The I/O ports, CPU, memory, timers, ADC, and DAC, they are all integrated in one chip, and they are all dedicated to do certain functions for a specific application. So if it's just doing specific functions, then the memory doesn't need to be large. The I/O ports shouldn't be that many, and the CPU doesn't have to be complex. In other words, microcontrollers are different from processors or microprocessors in many ways, and I listed some of them in this table. In microprocessors, memory and I/O components are connected externally, while they are connected internally in microcontrollers. Microprocessors typically have a RAM of 512 megabytes to 32 gigabytes and a ROM of 128 gigabytes to 2 terabytes, while microcontrollers have a RAM of 2 kilobytes to 256 kilobytes and a ROM of 32 kilobytes to 2 megabytes. Microprocessors have larger area excluding memory and I/O, while in microcontroller, everything is compact in one small chip. And since other blocks are external, microprocessors have longer routes, thus signals travel slower, while microprocessors have shorter routes, so signals travel faster. Microprocessors need faster processing. That's why it has a frequency of at least 1 gigahertz. Microcontrollers, on the other hand, are not required to process at gigahertz level. Their processing speed is only about 8 megahertz to 50 megahertz. And because of the higher processing speed, microprocessors have higher power consumption. External components will also add to that power consumption, while microcontrollers have lower consumption because it has lower processing speed. And since most components are inside the chip, overall, it consumes less power than general computer systems. Microcontrollers have power-saving mechanisms, while microprocessors generally don't. Microprocessors handles more complex tasks, while in microcontrollers, the tasks are limited and less complex. Microprocessors are also more complex to manufacture, while microcontrollers are cheaper, so it's ideal for mass production. And lastly, the programs inside a microprocessor can be changed for different applications, while in microcontrollers, the program is fixed once manufactured. Some popular microcontrollers include the PIC microcontroller by Microchip, which are usually used in electronics and robotics. There's the ARM microcontroller, which is the most popular in digital embedded systems because they are used in instrument control systems, wireless networks and sensors, and even in automotive industries. There's also the 8051 by Intel, and of course the MSP microcontroller by Texas Instrument, which is designed for low cost and low power embedded devices. In our course, we are going to use PIC microcontrollers. We'll have more discussions about this after the second long quiz. And that's the end of our lecture for this week. These are the references used in creating these lecture slides, but of course, you are welcome to use other resources in your personal studies.